Hi, I'm back with Life with Miss H. Today we're going to look at writing linear equations. I was asked about this from a student, Miss Jasmine. We're going to write it in slope-intercept form, and we're going to be writing from a table and a graph. So here we go. All right, when you're writing linear equations in slope-intercept form, it's a very simple process as far as setting up, because there's only two things that you need. For any equation, you need your slope and your y-intercept. When you look at your slope-intercept form, in the y equals mx plus b, your slope goes in for m, your y-intercept takes place of b. Now, the thing that you got to remember is, even though this says plus b, that's the base, the parent for the parent form of the equation, meaning that's kind of what it comes from. That's what you want it to look like. But at times your b can be negative, and you would just replace it with a subtraction sign. So try to avoid double signs like a plus minus. You don't want to really do that, because when you start using your equation, or if you need to use your equation, it will be a little complicated when you see that plus and minus and get you mixed up. So just use either plus for a positive, subtract for a negative. Over to the side, if you have kind of a table or a paragraph, to be able to find slope, you have to be able to pull 2 points off and use your y2, y1, x2, x1. So what you would end up doing is taking y2 minus y1 and dividing that by x2 minus x1. You also could hear that saying like the change in y or the change of x, which kind of simplifies down to rise over run, which is super easy to use, but that would require you having a graph. So what you could really do to kind of avoid a lot of the math work of it is to create you a graph, plot the points that you see on your table, and I'll talk to you a little later here in just a second on where you can get a table from. I'm not going to do that because really overall it takes longer to do, but not necessarily is it any more complicated. But your slope, those are two ways you can find your slope. Your y-intercept is going to be the point the graph crosses the y-axis. So wherever it crosses the y-axis, that's going to be your y-intercept. And there's really not a whole lot of work to find y-intercept when you're given a graph, but it is a little bit of work whenever you are given a table. So our first example is going to be a graph. If you kind of notice, the graph runs in a downward motion. So if I start like reading a book from left to right, I'd rather watch a movie though. You've got a line that runs, it starts high and runs low. That indicates a negative slope. So once you start counting your slope, you go from point to point. I could go down 1, 2, right 1. That would be my slope. Or if you went to the very last one, you would go down 4 and right 2, which would simplify to 2 over 1. So that's what I've kind of got over here. My slope, it goes down 2, right 1, so that would be a negative 2. Because you're going down, it would be a negative change. And your right 1 would be a positive 1. That simplifies to negative 2. In your equation, it would be y equals negative 2x. And then you come back over and your point at 3 crosses the y-axis. So this would be your y-axis, this is your x-axis. Crosses at 3, so your finished part of the equation would be plus 3. So your overall equation would be y equals negative 2x plus 3. When you come to a table, there's not really any great tricks to really tell you, because a lot of your shortcuts with a table depends on if it's proportional or not proportional. And there's not really any way to tell that. You could back it out to 0, like subtract back to 0, and see if it's 0, 0, then that would indicate proportional. But that takes a lot of work, because, for instance, if this 2, 4, and 6 was 44, 46, and 48, you'd be subtracting a whole lot to get down to 0. So it's easier just to kind of use your equation. So I'm going to bring in the y2 minus y1 over x2 minus x1. here's my y's. So I picked 13. This 413 could be a point, 2 7's a point. I done 13 minus 7, which gives me 6. 4 minus 2 is 2. 6 divided by 2 is 3. So this graph would be going up 3. And then this would be my small equation point now. To see if I have a y-intercept, I want to pick another point. I can pick any of these points that I want. I picked 2 and 7 because they're the smallest numbers. When I plug 2 in for x, 7 in for y, 3 times 2 gives me 6. I need it to be 7 so they're not equal to each other. So to get 6 to 7, I have to add 1. So your finished equation would be y equals 3x plus 1. Your slope is 3, so it goes with your x, and then the plus 1 is your y-intercept. Okay, so since I got two examples kind of worked out, let's just kind of work 2 out from scratch. That way you can kind of see where everything comes from. If you're given a graph, you really can start with the y-intercept or the slope, whichever one you want. It don't really matter. I'm going to go ahead and start with a y-intercept because that's kind of the easiest thing that everybody should be able to see. When you come to the y, so remember this is your y-axis, down here is your x-axis. I come to the y and it crosses at 1, so I can go ahead and bring down the x, and in place of this b, I want to put plus 1. To get my slope, I'm going to start at this point and I want to go over to this point. To get from here to here, I go up 1 and right 1, 2, 3. So the change in y over x is 1 over 3. So my new equation, or I guess my finished equation, would be y equals 1/3 x plus 1. All right, so we'll work on a table. First, I'm going to find slope by using y2 minus y1 over x2 minus x1. And I can pick any of these that I want. I got to pick 2 of them. So I'm going to pick 311, 521. That would be the points 311, 521. When I substitute in, this could be y2, x2, y1, x1. So you get 21 minus 11. 5 minus 3, I get 10 over 2, which is 5. So that allows me to write y equals 5x. I want to check to see if I have a y-intercept. So I want to take this 311 and I want to substitute it into my equation. So I'm going to put 11 in for y. I'm going to put the 3 in for x, and I get 11 equals 15. That does not equal each other. So I want this 15 to be 11, so I have to subtract 4 to get it to be 11. So on my equation, that y equals 5x, whatever I times 5 by, once I get that total, I need to subtract 4 from it, and that would be your overall final equation. I hope this helps. Make sure that you subscribe to Life with Miss H while you're here looking at it, because this is going to the famous YouTube. And if it does not help, I apologize, and I might can make you another one. Peace out. I'm back with Life with Miss H. Today we are going to talk about writing linear equations from tables and a graph. So, not good. It's not good. Start it over.